NASA's X-59. Step into the realm of supersonic possibilities, where speed meets innovation in the quest for silent skies. Since 1947, humanity's fascination with breaking the sound barrier has driven aerospace engineers to push the limits of flight. From Chuck Yeager's groundbreaking flight in the X-1 to modern-day experimental aircraft, the journey towards supersonic speeds has been one of exhilaration and challenge. Yet, amid the excitement of breaking barriers, a formidable obstacle stands in the way: the sonic boom. Imagine a thunderous roar shattering the tranquility of the skies, rendering supersonic flight a luxury confined to remote areas or military operations. This explosive shockwave, a byproduct of exceeding the speed of sound, poses risks to both infrastructure and public safety, limiting the dream of widespread supersonic travel. But what if there was a solution? What if innovation could tame the thunder and pave the way for a new era of silent supersonic travel? Enter NASA's X-59, a revolutionary aircraft designed to silence the boom and unlock the full potential of supersonic flight. Join us as we delve into the science, engineering, and promise of this groundbreaking project, exploring how it could redefine the future of aviation and shape the skies of tomorrow. From the challenges of design to the potential for global impact, this is a story of ingenuity, perseverance, and the relentless pursuit of progress in the skies above. Since the historic moment when Chuck Yeager shattered the sound barrier aboard the Bell X-1 in 1947, humanity has been on a relentless quest to conquer the skies at ever greater speeds. The achievement marked a pivotal moment in aviation history, opening the door to a new realm of possibilities and sparking the imagination of generations to come. From that point forward, the race to push the boundaries of flight has been one of innovation, ambition, and the relentless pursuit of progress. However, with every stride forward, there comes a challenge to overcome. In the case of supersonic flight, this challenge manifests in the form of the sonic boom, a thunderous shockwave produced when an aircraft exceeds the speed of sound. This explosive noise, akin to a thunderclap, reverberates across the sky, disturbing the peace and posing significant challenges to widespread supersonic travel. The problem of the sonic boom is not merely a nuisance, it is a fundamental barrier to the realization of supersonic travel's full potential. As aircraft travel faster than sound, they generate shockwaves that propagate outward, creating a disturbance that can be felt and heard on the ground below. This phenomenon not only disrupts communities and wildlife but also raises concerns about structural damage and potential health hazards. For decades, the sonic boom has served as a formidable deterrent to the widespread adoption of supersonic flight, relegating it to niche applications such as military operations or transoceanic travel. Yet, the allure of faster travel times and the promise of a more connected world continue to fuel interest in overcoming this barrier. The need for a solution is clear. If supersonic flight is to become a viable option for commercial travel, the issue of the sonic boom must be addressed. Enter NASA's X-59, a bold endeavor that seeks to revolutionize supersonic travel by mitigating the effects of the sonic boom. Developed in collaboration with Lockheed Martin, the X-59 represents a cutting-edge approach to aircraft design, leveraging advanced technologies and innovative engineering principles to achieve the seemingly impossible, silent supersonic flight. In this exploration of the X-59 project, we will delve into the science, engineering, and implications of this groundbreaking endeavor. From the history of supersonic flight to the challenges of sonic boom reduction, we will uncover the motivations driving this ambitious undertaking and the potential it holds for the future of aviation. Join us as we embark on a journey through the skies, where speed meets innovation in the quest for silent sonic booms. From the challenges of design to the promise of revolutionizing air travel, the story of the X-59 is one of ingenuity, perseverance, and the relentless pursuit of progress in the realm of supersonic flight. A sonic boom is a thunder-like noise that occurs when an aircraft or other aerospace vehicle flies faster than the speed of sound. As per NASA, when an object travels through the air at supersonic speeds, it displaces air molecules with great force, creating a shockwave. This shockwave propagates outward in all directions, similar to the way ripples form when a stone is thrown into a pond. The result is a sudden and intense noise, often described as a loud clap or thunderous roar, that can be heard by people on the ground beneath the aircraft's flight path. The sonic boom's impact extends beyond mere noise pollution. It poses significant risks to both structures and public safety. The intense pressure waves generated by supersonic flight have the potential to cause structural damage to buildings and other infrastructure. Furthermore, The abrupt and unexpected nature of sonic booms can startle individuals, leading to safety concerns, especially in densely populated areas. In response to these risks, regulations governing supersonic flight over land have been put in place in many countries. These regulations typically restrict or prohibit supersonic flight over populated areas to minimize the sonic boom's impact on communities and infrastructure. Exceptions are often made for military operations or emergency situations, where the benefits outweigh the risks. Reducing the intensity of sonic booms is crucial for unlocking the full potential of supersonic flight. By mitigating the disruptive effects of sonic booms, aircraft could be permitted to fly at supersonic speeds over land without posing undue risks to people or property. This would open up new possibilities for commercial supersonic travel, allowing for faster and more efficient transportation options. Furthermore, reducing sonic booms could lead to advancements in military aviation, enabling stealthier operations and greater tactical flexibility. By overcoming the limitations imposed by sonic boom regulations, aircraft could operate more freely, expanding their range and capabilities. In summary, reducing sonic booms is essential for expanding the scope and viability of supersonic flight. By addressing the challenges posed by sonic booms, such as noise pollution and structural concerns, the aviation industry can usher in a new era of faster, more efficient, and more accessible air travel. The X-59 aircraft represents a collaborative effort between NASA and Lockheed Martin, two giants in the aerospace industry. This partnership brings together NASA's expertise in aeronautical research and exploration with Lockheed Martin's experience in aircraft design and manufacturing. The collaboration underscores the shared commitment to advancing the frontiers of aviation and overcoming the challenges associated with supersonic flight. The partnership between NASA and Lockheed Martin combines cutting-edge technology, innovative engineering, and decades of experience to tackle one of the most significant obstacles to supersonic travel, the sonic boom. By pooling their resources and expertise, NASA and Lockheed Martin aim to develop a revolutionary aircraft capable of achieving supersonic speeds while minimizing the disruptive effects of sonic booms on the ground below. The primary objective of the X-59 aircraft is to achieve supersonic flight, while significantly reducing the intensity of the sonic boom it produces. Unlike traditional supersonic aircraft, which generate loud and disruptive sonic booms, the X-59 is designed to produce a much quieter and more tolerable sonic thump. This breakthrough in sonic boom reduction could pave the way for the widespread adoption of supersonic travel, opening up new possibilities for commercial and military aviation. By achieving supersonic flight with reduced sonic boom, the X-59 has the potential to revolutionize air travel, making it faster, more efficient, and more accessible than ever before. This groundbreaking technology could enable aircraft to fly at supersonic speeds over land without causing disturbances to communities or infrastructure, overcoming one of the primary barriers to the commercialization of supersonic flight. It's important to note that the X-59 project is still in the experimental phase. As an experimental aircraft, the X-59 is not intended to be a prototype for a commercial airliner or to carry passengers. Instead, it serves as a platform for testing and validating new technologies and concepts related to sonic boom reduction. The experimental nature of the X-59 project allows researchers and engineers to explore innovative approaches to supersonic flight without the constraints of commercialization or mass production. By pushing the boundaries of what is possible in aviation, the X-59 project aims to lay the groundwork for future advancements in supersonic travel and shape the future of air transportation for generations to come. Central to the X-59's mission of reducing sonic boom is its sleek and aerodynamic design. Every aspect of the aircraft's shape and structure has been meticulously crafted to minimize air disturbance and streamline airflow during supersonic flight. The X-59's slender fuselage, swept-back wings, and carefully contoured surfaces work together to minimize drag and turbulence, allowing the aircraft to cut through the air with minimal resistance. By reducing air disturbance, the X-59 is able to generate a smoother, more gradual transition from subsonic to supersonic speeds, thereby minimizing the intensity of the sonic boom produced. This emphasis on aerodynamic efficiency not only improves the aircraft's performance but also plays a crucial role in achieving the project's goal of silent supersonic flight. One of the most striking features of the X-59 is its unconventional cockpit design, which eschews traditional front-facing windows in favor of advanced camera systems and display technologies. Unlike conventional aircraft, which rely on pilots' direct visibility through cockpit windows, the X-59's cockpit is equipped with external cameras mounted on the nose cone. These cameras provide real-time video feeds to the pilot's display screens, allowing for a panoramic view of the surrounding airspace. The absence of front-facing windows not only contributes to the X-59's sleek and streamlined profile but also plays a crucial role in reducing air disturbance and sonic boom intensity. By eliminating the need for large, protruding cockpit windows, engineers were able to optimize the aircraft's aerodynamic performance and minimize disruptions to airflow during supersonic flight. This innovative approach to cockpit design exemplifies the X-59's commitment to pushing the boundaries of aviation technology in pursuit of silent supersonic flight. In addition to its aerodynamic design and cockpit innovations, the X-59 incorporates advanced engine placement and other cutting-edge technologies to further reduce sonic boom intensity. Unlike traditional aircraft, which typically feature engines mounted beneath the wings or fuselage, the X-59's single General Electric F414 engine is mounted in the top of the tail section. This unique engine placement helps to minimize the impact of engine noise and airflow disturbances on the aircraft's sonic signature, contributing to a quieter and more subdued sonic boom. Furthermore, the X-59 utilizes a range of other technologies, such as custom-designed airfoils and specialized materials, to further optimize its aerodynamic performance and sonic boom characteristics. By leveraging these innovative design features and technologies, the X-59 aims to achieve supersonic flight with a significantly reduced sonic boom, paving the way for a new era of silent supersonic travel. In the realm of aerospace engineering, computer modeling has emerged as a powerful tool for advancing aircraft design and development. By simulating the complex physics and dynamics of flight in virtual environments, engineers can explore a wide range of design concepts and scenarios with unprecedented speed and accuracy. Computer modeling allows for the rapid iteration and refinement of aircraft designs, enabling engineers to optimize performance, efficiency, and safety parameters before physical prototypes are ever built. The X-59 project harnesses the power of advanced computer modeling techniques to inform every aspect of the aircraft's design and development process. From aerodynamic analysis and structural integrity testing to sonic boom prediction and mitigation, computer simulations play a central role in shaping the X-59's final configuration. By leveraging state-of-the-art modeling software and high-performance computing resources, NASA and Lockheed Martin engineers are able to explore innovative design solutions and evaluate their impact on sonic boom reduction with unparalleled precision and efficiency. Traditionally, concept testing in aerospace engineering relied heavily on physical prototypes, wind tunnel testing, and sensor data collection to evaluate aircraft performance and behavior. While these methods provided valuable insights, they were often time-consuming, resource-intensive, and limited in scope. Additionally, the complexities of supersonic flight and sonic boom generation pose significant challenges for traditional testing approaches, necessitating innovative solutions to overcome these limitations. In contrast, modern computer simulations offer a more efficient and cost-effective alternative to traditional concept testing methods. By creating detailed digital models of aircraft designs and simulating their behavior under various conditions, engineers can gain insights into performance characteristics and identify potential design flaws before physical prototypes are constructed. Furthermore, computer simulations enable engineers to explore a much broader range of design options and scenarios than would be feasible with traditional testing methods, accelerating the design iteration process and reducing time to market for new aircraft concepts. While computer modeling is invaluable for informing and refining aircraft designs, real-world testing remains an essential component of the validation process. Despite the sophistication of modern simulation tools, there are aspects of aircraft behavior and performance that can only be accurately assessed in a physical environment. Real-world testing allows engineers to verify the accuracy of computer simulations, validate theoretical design assumptions, and assess the practical feasibility of proposed solutions. For the X-59 project, real-world testing serves as a critical step in validating the effectiveness of sonic boom reduction technologies and confirming the aircraft's ability to achieve supersonic flight with minimal disturbance. By conducting test flights and collecting empirical data, NASA and Lockheed Martin can evaluate the X-59's performance in actual flight conditions, identify any unforeseen challenges or limitations, and refine the aircraft's design accordingly. Ultimately, real-world testing provides the empirical evidence needed to demonstrate the viability of theoretical designs and pave the way for the practical implementation of innovative aerospace technologies. Despite ambitious plans and meticulous preparations, the X-59 project has encountered delays in its journey towards the first test flight. Originally scheduled for autumn of 2021, the inaugural flight was postponed due to various factors and challenges encountered during the testing phase. These delays, while frustrating, are not uncommon in the development of groundbreaking aerospace technologies, where unforeseen obstacles and complexities often arise. The delays in the initial test flight highlight the importance of thorough testing and validation processes in aerospace engineering. From ensuring the structural integrity of the aircraft to fine-tuning its sonic boom reduction technologies, every aspect of the X-59's design must be rigorously evaluated before it takes to the skies. While delays may prolong the development timeline, they ultimately serve to ensure the safety, reliability, and effectiveness of the final product. Despite the setbacks, progress continues to be made on the X-59 project, with preparations underway for the final assembly and testing phase. The aircraft, which underwent stress testing and fuel system calibration in Fort Worth, Texas, has been relocated to Lockheed Martin's Skunk Works facility in Palmdale, California, for final assembly and preparation for its maiden flight. At the Skunk Works facility, engineers and technicians will meticulously assemble the X-59, integrating its various components and systems to ensure optimal performance and functionality. The aircraft will undergo rigorous testing and validation procedures, including ground tests and system checks, to verify its readiness for flight. Once all preparations are complete, the X-59 will be poised to embark on its historic journey into the skies. Following the X-59's inaugural test flight, NASA plans to conduct overground testing to gauge public feedback and assess the aircraft's sonic boom signature. These tests will involve flying the X-59 over various cities and towns, allowing residents to experience firsthand the reduced sonic boom produced by the aircraft. NASA will solicit feedback from the public to evaluate the perceived loudness and acceptability of the sonic boom, helping to inform future decisions and regulations regarding supersonic flight over land. The participation of communities in overground testing underscores NASA's commitment to transparency and public engagement in the development of aerospace technologies. By involving the public in the testing process and soliciting their feedback, NASA aims to foster greater understanding and acceptance of supersonic flight and its potential impacts on communities. Ultimately, the success of the X-59 project depends not only on technological innovation but also on the support and acceptance of the people who will be affected by its implementation. The successful development of technologies to mitigate sonic boom could pave the way for the lifting of bans on commercial supersonic flight over land. Currently, stringent regulations restrict supersonic flight over populated areas due to the disruptive nature of sonic booms. However, if the X-59 and similar projects prove effective in reducing sonic boom intensity to acceptable levels, regulatory bodies may reconsider these restrictions, opening up new opportunities for commercial supersonic travel. The lifting of bans on commercial supersonic flight could revolutionize the aviation industry, unlocking new markets and routes previously inaccessible to traditional aircraft. By enabling faster and more efficient travel over land, supersonic aircraft could offer a competitive advantage over conventional airliners, appealing to business travelers, time-sensitive passengers, and luxury clientele alike. With the potential relaxation of regulatory restrictions on supersonic flight, aerospace manufacturers are already exploring designs for future commercial supersonic aircraft. Drawing inspiration from projects like the X-59, these next-generation aircraft aim to combine cutting-edge technologies with sleek, aerodynamic designs to minimize sonic boom and maximize efficiency. From small-scale business jets to larger passenger airliners, the future of commercial supersonic travel holds promise for a diverse range of aircraft designs. Companies like Lockheed Martin, Boom Supersonic, and others are actively developing concepts for supersonic aircraft capable of carrying passengers across continents at unprecedented speeds. The advent of commercial supersonic travel promises to revolutionize the future of air travel, offering faster journey times and expanded route networks. With supersonic aircraft capable of flying at speeds exceeding Mach 1, travel times between distant cities could be reduced by half or more, making previously impractical journeys feasible and accessible. For example, a flight from New York to London could be completed in just a few hours, compared to the current transatlantic crossing time of approximately 6 hours. Similarly, routes connecting major hubs across continents could be serviced in a fraction of the time it takes with conventional aircraft, opening up new possibilities for international travel and commerce. In conclusion, the successful development and adoption of technologies to mitigate sonic boom have the potential to revolutionize air travel and revive supersonic passenger flights. By overcoming the barriers to supersonic flight, such as noise pollution and regulatory restrictions, the aviation industry can usher in a new era of faster, more efficient, and more accessible air travel. The promise of silent supersonic flight opens up a world of possibilities for travelers, businesses, and communities around the globe. From shorter travel times to expanded route networks, the future of supersonic travel holds immense potential to reshape the way we experience the world. As projects like the X-59 continue to push the boundaries of aviation technology, the dream of supersonic passenger flights may soon become a reality once again. In conclusion, the journey towards silent supersonic flight represents a pivotal moment in the evolution of aviation technology. By reducing the disruptive effects of sonic boom, projects like the X-59 hold the key to unlocking the full potential of supersonic travel. From faster journey times to expanded route networks, the implications for the future of air travel are profound. As we look ahead, there is reason to be hopeful for the future of aviation. With advancements in technology and the dedication of pioneering engineers and researchers, the dream of supersonic passenger flights may soon become a reality once again. The X-59 project serves as a testament to the power of innovation and collaboration in overcoming the challenges of supersonic flight. As we embark on this journey towards the future of air travel, let us remain vigilant in our pursuit of progress and exploration. By continuing to push the boundaries of aviation technology, we can unlock new frontiers and redefine the way we experience the world. That said, thanks for watching, and don't forget to like, share, and subscribe for more exciting aviation content. Until next time, fly high and stay adventurous. Thanks for watching.